Hi there, and welcome to part 4 in the UnityFS aircraft tutorial series. In this part we're going to look at how to add control surfaces to our wings to allow us to control the aircraft and fly around, and also how to use real-world aerofoil data to make the wings behave much more realistically. So to get started, the first thing we're going to do is head to the top-down view and switch to overdraw mode as before to give us this nice X-ray view of the aircraft. We can see our wings here that we've got set up before, and we're now going to add control surfaces to them so that we can fly the aircraft around. So as before, we'll start on the right wings first, and we're going to add an aileron to the outer right wing. So I'm going to select this section of the wing by clicking on the wing gizmo, and then to add a control surface, all I need to do is go to the component menu, go to UnityFS, go to Dynamics, and select a control surface. Now you notice as soon as I've added a control surface that this purple line appears on the wing itself. And this is the hinge line for our control surface. So the control surface will hinge at this line and will move behind it, so from the purple line back to the trailing edge. Now we can see here on the model where the actual aileron lies itself. It's this part of the mesh here, the lighter line, and we can use the control surface component to actually just tweak the control surface hinge points to make it line up with the aileron. So you can see here there's the root hinge offset. If I tweak this, I can really easily define where the starting point of the aileron is. So we'll get that to line up with the hinge point there. And then we can do the same for the tip offset, like so. So now that we have our control surface hinge line lined up nicely, we can then select which sections of the wing we want to move with the control surface. And we can do that by simply checking the box is in the affected sections column here that we wish to use. So by checking these sections, I'm telling UnityFS that these are the parts which I wish to move on this control surface. You can see here that at the end there's a slight gap here. We can increase this by adding more sections to our wing. The more sections we have, the more sections we can then tick here, and the higher resolution we can have for our control surfaces. But for now, this is only a tiny gap. This will do fine. You'll notice as before, as we have our mirror component set up, that as soon as we add the control surface and check all of the affected sections, that the mirrored wing, in this case the left outer wing, will automatically pick up all of the control surface areas. So now we have the area defined. In the editor window, in the scene window, we can define how this moves. And to do that, we first of all need to give it an input, so a control input that we can use to move it. So in here, we do that simply by typing in an axis name in here. And in this case, we're just going to type in roll, which is what we use the left and right keys for to roll the aircraft. You can set custom axis names here by editing the input manager settings in the project. So if we go to edit, project settings, input, you can see all the axes we have defined here. These are all custom axes defined for UnityFS. You'll find these included with the project file, so you can just drop this file in to have all these automatically. So coming back to our object, you can see that on the wing here now, we have the axis name defined as roll, we have our hinge point set up, and finally we can set the maximum deflection in degrees here to allow the control surface to move. 30 degrees deflection gives us 15 degrees upward deflection and 15 degrees downward deflection, and is about average. This is what I would expect to find on most aircraft. So now we've done that, we can do the same for the tailplane and also for the rudder. So I'm just going to go through these quickly. Select the tailplane, again, add my control surface, and then tweak it so that it lines up. Set the axis name, in this case, to be pitch, and we'll leave the deflection at 30. In this instance, I'll set all of these parts to move. And then for the rudder, we will add another control surface. Move the hinge lines. In this instance, we want pretty much the whole of the surface to move. In fact, we will make it the whole surface. That's absolutely fine. And we will use our predefined yaw axis again with 30 degrees, and we will tick all of these. The next step with the control surfaces really is to check that they all move in the correct direction. We have this invert box here that we can check, so if any of them are moving in the wrong direction, we can check this and cause them to invert the direction in which they move. Wings are designed in such a way that they should automatically invert, because we have the scale here, positive on this side and negative on this side. Then this aileron by default will rotate into the opposite direction of this one. So in these instances we shouldn't actually need to use the invert tool. But to test this, we'll simply press the play button, go to our outside view, and then start turning left and right. I can see here that if I want to try and turn to the right, so I'm just pressing the down key here, I can see that this aileron's moving down, which would lift this wing up, which is correct. And this one's moving up, so the ailerons look like they're actually set up correctly. If I try and yaw, I can see that this is actually the wrong way around at the moment. And if I try and pitch, interestingly I can see that these are both moving in opposite directions, and it looks like this one's wrong. So I have two surfaces that I need to invert. So I shall select the rudder here, which is this surface, and then invert it, and I shall select this tail fin here or elevator and invert it. And now if I press play, I can see that the ailerons are moving in the correct direction. The rudder, I don't know if you can see the white line, is moving in the correct direction, and also the tail plane is moving in the correct direction. Now, as you will have noticed, whilst the debug drawing is showing the correct movement for all these surfaces, the actual model itself isn't moving. I'll discuss how to rig the model to move in a later video. So we now have our aircraft set up, we have our wings, we've got our control surfaces. The next really important thing is to look at the wings themselves and how they perform. So if we click on our wing here, you'll notice that on the wing component it says that no airfoil is selected using basic lift drag equations, and that's exactly what the simulation is doing at the moment. We haven't given it any specific data as to the type of wing this is, so it's just going to perform loose approximations of how it thinks the aircraft should fly. We can actually go way better than this with UnityFS. UnityFS includes a library of lots of existing real-world aerofoils. There's over 1,000 of them. If you go into the prefabs directory and into the library folder, you'll notice that in here there are over 1,000 aerofoils, and so it's very likely that the aircraft you're trying to create, you'll be able to find the exact aerofoils that you need to use here. And if I click on one of these, you can see that up here it has this curve data here, which has the lift, drag and moment coefficients for that particular aerofoil, and that really is just describing how the wing should perform given angles of attack. So with that in mind, what I can do now is go onto the internet and look at the wing aerofoil that is used for the particular aircraft that we're modeling. In this instance we're making a Cessna 170, and so if I just search this document for 170, I can see that the wing airfoil that's being used is a NACO 2412. So if I come back into UnityFS, select my wing, and scroll through the airfoil prefabs down to N, I can find the NACO 2412 and drag that onto my airfoil. You'll then see that the lift, drag and moment coefficients are populated from that prefab. So I'll do that again for the middle section. And we'll see that this is picked up for the opposite wings, again because we're using the mirror component. For the tail sections, I'm actually just going to skip ahead slightly and just pick some generic aerofoils for this, just to save time. And what I'm going to do is pick a symmetrical aerofoil. Most aerofoils are not entirely symmetrical. If you were to look at them, you'd see that the top surface is raised and the bottom surface is flat, and that means that the upper surface is going to produce a lot more lift than the lower surface, so the aircraft would fly much better the right way around. upright, sorry, as opposed to upside down. With the tail surface, with the rudder, and also with the elevator, we don't necessarily want this kind of behavior. We want the rudder to generate lift equally, regardless of whether you're going left or right. So we're going to use a symmetrical aerofoil for both of these surfaces to try and make it feel right. Again, you can probably find out the specific aerofoils that are used for each of these surfaces online, but just to save time, I'm going to go into the prefabs aerofoils directory and close the library folder, and in the top level there's two very generic aerofoils that we can use. So I'm going to use the symmetrical aerofoil on the tail plane, on the front of the vertical stabilizer, and also on the back on the rudder. And you can see that on the mirrored components this has already been picked up. And that's it. We now have our aircraft rigged up with control surfaces which are driven by input, and we have used custom advanced aerofoils to drive the model as it would behave in real life. So let's hit the play button. You can see the tail wheel start to fly as we build up speed. And then if we pull back on the stick, we can see the aircraft start to fly. If you look at the top of the wing here, you can see the green lines which represent the lift that is being generated by the wing. So we can roll the aircraft left and right. We can pitch up and down. And we can also yaw left and right.